Okay, in this part of the section, we're going to be working with drawing graphs. So this is just kind of a piece that's going to help us with some wording to begin with. So we're going to review a little bit. It says match the verbal description with the part of the graph that it describes. So it says stays the same. So we kind of discussed this previously. So here we've got some pieces. This would show an increase here. Here on letter E, we have an increase. B is also an increase. C, we have a decrease. D, we have a decrease. And F would be where it stays the same. So this would be letter F. Slowly decreases at a constant rate. So we either have C or D, and if it slowly decreases, well, that's going to be letter C there. Slowly increases at a constant rate. So it's either A, B, or E. So constant means it's going to be a straight line, and if it's slow, it's going to be a lower slope. So that would be letter A. Increases at an increasing rate. So we're left with B and E. So when it says increases at an increasing rate, that's not going to be a constant or a straight line. It's going to be showing where it's getting faster over a period of time. So that would be letter E. Quickly decreases at a constant rate. That's our quick decrease would be letter D there. And quickly increases at a constant rate would be letter B. Okay, so we're going to go ahead and kind of practice drawing some of these. So this is very similar to what we did in our previous part of this lesson. So we've got decreases at a high constant rate. So if it says constant, constant means it's going to be a straight line. So if it's high, that means it's going to be a high slope or a very steep slope. So if it's decreasing, that's left to right. We're going to have something that looks like that. Okay, rate stays the same. So if it stays the same, that's going to be a flat line. It's not changing at all. Increases at a low constant rate. So we have low would be a low slope, so not a very steep slope. And constant is going to be a straight line, so maybe something that looks like this. Increasing at an increasing rate, that's going to be where it's kind of going up in a curved fashion, so something like this. It's increasing at an increasing rate, not a straight line. Decreasing at a low constant rate, so low once again is going to be a shallow slope, and it's dropping from left to right. Decreasing at an increasing rate, so it's dropping. Decreasing, increasing rate is going to be a curved line. And increasing at a high constant, so it's an increase. Constant, straight, high would be steep slope. Okay, so we're going to use some of these to go ahead and piece them together and create some graphs. All right, so let's move this out of here. Okay, so here's the thing is when we're sketching graphs, there's a couple steps that we need to follow. We're going to draw our axis lines, label the vertical axis line with speed in this scenario, and the horizontal with time. So we've got kind of an L shape. Whoops. There's our axis lines. Vertical is going to be our up and down. That's going to be speed. And horizontal is time. Okay, so let's read the scenario. It says a stopped subway train gains speed at a constant rate until it reaches maximum speed. So gains speed at a constant rate. Gains speed at a constant rate is going to be a straight line. Until it reaches its maximum speed, it travels at this speed for a while. So it's maintaining its speed, flatlining. It then slows down at a constant rate until coming to a stop at the next station. Slows down at a constant rate. Okay, remember constant's going to be using a straight line. So that is working through and graphing out a scenario. So we're going to try a few more of those. So your first thing is to set up your axis lines. Okay, so we have as television size increases, the price increases at an increasing rate. Okay, so here we've got in our scenario, our TV size, as it increases, the price is going to increase. So we'll do our price here. and our TV size here. Okay, so as our TV size increases, gets bigger in size, our price is also going to increase. It's going to be at an increasing rate. So it's going to increase at an increasing rate, not a constant rate. So it's going to kind of be something that looks like this. Okay, it's not like every TV goes up by a specific amount. It's just as it increases in size, it slowly changes over time. So you're going to have kind of a curved line for that scenario. Okay. Okay, so we have a fully charged battery here. Okay, so we have a fully charged battery, loses its charge at a constant rate, so we're going to be using a straight line, until it has no charge left. You plug it in and recharge it fully. Then it loses its charge at a constant rate until it has no charge left. Okay, so let's start with doing our access lines. And we're going to do our time over here, or down here. And then this would be our charge, or energy, whatever you want to put. So a fully charged battery, so it's going to start off at a high charge. So we're going to start off somewhere up here, right? Because it's going to start off at a high charge. And it says it loses its charge at a constant rate until it has no charge left. So we're going to drop down at a constant rate until we're down to 0, no charge left. We plug it in and recharge it fully. So now it's recharging at that constant rate. Then it loses its charge at a constant rate until it has no charge left, and so forth. So that's what our picture would look like if we were to go through and graph charging of a battery, okay? Remember, the word using constant is using a straight line. All right, let's try one more. Okay, a soapbox derby car picks up speed at a constant rate as it travels downhill. Okay, so we've got speed and time. And the wording was at a constant rate. So a soapbox derby car picks up speed at a constant rate. So we're going to be, remember, our speed's going up here, right? So constant rate, it's going to be going up. It continues to pick up speed until the racer applies the brakes after crossing the finish line. Okay, so applies the brakes. It says once the brakes are applied, the car decreases speed at a constant rate until it stops completely. So it's going to increase speed, and then it's going to start to put on the brakes, and it's going to put on those brakes and slow down at a constant rate until it comes to a complete stop. So there's our soapbox scenario. All right, that's it for this lesson. Key thing is to just keep trying and plugging away, remembering that constant means a straight line. An increasing of an increase or decrease, you're going to have a curved line. Good luck.